Hello everyone, welcome to the video tutorial of Isol. This time we will be talking about one of the two line drawing algorithm, which is a digital differential analyzer, or simply known as DDA line drawing algorithm. There are two types of line drawing algorithms. The first one is digital differential analyzer, DDA. It samples the line at unit intervals in one coordinate and determine corresponding integer values nearest the line path for the other coordinate. The second one is Bresenham line algorithm. It scans, converts lines using only incremental integer calculations. Let us talk about DDA. A scan conversion line algorithm based on calculating either delta y or delta x using line points calculating equations. In its case, choosing the sample axis depends on the slope value. The unit step for the selected axis is 1. The other axis is calculated depending on the first axis and the slope m. The next slide will show the different cases of the slope. So what we have here is that we have two axes. This is your y-axis, and then we have x-axis. We will calculate the value of m, and according to the value of m, we will have a unit step for axis. Suppose we have unit step for axis x. That means for every algorithm, for every repetitive steps, we will calculate 1, 2, 3, 4, 5, 6, 7, 8, and so on the x-axis. And then we will calculate the value corresponding to these 1, 2, 3 unit steps on the x-axis for the y-axis. Okay, we will try to understand this using an example. Now, there are two cases. In fact, there are four cases where we will calculate the slope of the line. And the first case is when the slope is positive and less than 1. That means if the slope m is less than 1 but is greater than 0, that means m will be positive. In this particular case, this is case 1, sample at unit x interval, delta x will be 1. That means we will calculate along the x-axis. For every steps, x will be incremented by 1, and compute each successive y values as, try to remember this formula, yk plus 1 equals to yk plus m, means the next value of y will be the previous value of y plus m. Okay, suppose the next value of y is y2, it will be equals to the previous value of y, that means y1 plus the value of m. This is the formula. K takes integer value starting from 1 at the first point and increasing by 1 on each step until reaching the final endpoint. The calculated y must be rounded to the nearest integer, always rounded to the nearest integer. Now let us take an example. Describe the line segment which starts at 3, x13, y13, and ends at x2, 23, and y2 equals to 7. Now this is an example. Here this point is 3 by 3. That means x1 is 3, y1 is also 3. Here the endpoints, the other endpoints will be 23 by 7. Okay, so if we calculate this, we already know the formula of m, that m is equals to y1 minus y2 by x1 minus x2, or in other words, we can also use y2 minus y1 divided by x2 minus x1. This will give the same results. So when we calculate this, we know that y2 is 7 here, minus y1, which is 3, divided by x2, 23, minus x1, 3. And we calculate out this, the value of m is 0.2. Now this is satisfying the first case, where m is less than 1 and m is greater than 0. This case is satisfied. Okay, 0.2. Now in this particular case, what we have is that, as a rule, when m is between 0 and 1, x should be taken as unit step. Alright, as we have seen before, the value of y k plus 1 is equals to y k plus m. This is your formula. Alright, now let us see how we can draw a line like this. As we can see, delta x is equals to 1. That means the change of the pixel on the x-axis should always be unit step. That means here 3, 4, 5, 6. For every step it will take unit step. 3, 4, 5, 6, 7, 8, 9, 10 and so on up till 23. Okay, so this particular x will be simply unit step. That means x k plus 1 is equals to xk plus 1. It will be simply incremented by 1. Alright, this particular x should be simply incremented by 1. The initial points that we have here is x equal to 3, x1 equals to 3, and y1 equals to 3. This is the actual points, and this is the pixel position. So the first point is okay. Here the first point is okay. Now we're trying to find the value for the second points. As we know, x will be simply incremented by 1. 3 plus 1 is equals to 4. No problem. And the value of y should be, as the formula goes, yk plus 1 is equals to yk plus m. And we know that the value of m is already 0.2. We calculated in the previous slides. That means the new value of y should be the previous 3 plus m, which is 0.2, and then we get 3.2. Okay, I think we get this. That means the previous value of, here say that is y2, will be y1 plus m, which is equals to y1 is 3 plus 0.2, which is equals to 3.2. Alright, this is how we come to the conclusion. But this 3.2 is a decimal. We have to remove the decimal points, so that we will round down these decimal points to 3. Okay, this is the next pixel position. In the next position, we have x equals to 4 and y equals to 3. Still here. Likewise, it will go on. Next will be 3.2 plus 0.2, that is 3.4, and here we have 3.4. But still, this 3.4 should be round down to 3 because it is less than 0.5. Here we get 5 and 3. So the next pixel will be, location will be x equals to 5 and y equals to still 3 here. The next point here we have is 3.4 plus 0.2, which is 3.6. Now 3.6 is greater than 3.5, so we can round up to 4. Then the next coordinate on the x-axis is 6, and the coordinate on the y-axis will be 4. So if you calculate like this, it will move on. So m kha positive ani a 1 ayat lem box si chuan x-axis lam pangjok a increment naka pakhat te ten increment top don tin ani 3 4 5 6 ti kan increment char charang hei lampang hi chu basic y ve zo ka hi kan calculate anga y kan calculate dan tur kha chu y kan next kan calculate tur kha ama value y value plus m chu song chu ni mai hi case number 1 alo ni ta a. Case number 2 chuan case number 2, the slope is positive and greater than 1. A slope kha a positive it is greater than 1 plus 1. 1 aya atam vet hung chuan we will take the unit step on the y-axis. Okay, chuan the formula that we have is x k plus 1 will take the value of xk plus 1 by m. So the only difference here is that instead of having plus m, we have 1 by m. Okay, k takes integer value starting from 1 at the first point and increasing by 1 on each step until reaching the final endpoint. The calculated x must be rounded to the nearest integer. Example, describe the line segment which starts at 3,3 and ends at 723. So let us give an example here. This particular points is starting at 3 on the x-axis and 3 on the y-axis, and ends at 7 on the x-axis and 23 on the y-axis. When we calculate this, we know the formula already. M equals to 23 minus 7 divided by 7 minus 3, which is 20 by 4, and then we have 5. Now the value that we calculated out is much larger than plus 1. Okay, in this particular case, the value of changes in the y-axis will be 1, as we can see from here. Now the formula here we have is that xk plus 1 will be equals to xk plus 1 by m. As we know, 1 by m is equals to 0.2, alright, which is equals to xk plus 0.2. This is the formula. Now let us try to find out all these steps. Here, this is what we have. When m is greater than 1 on the positive side, y-axis should be given as delta y. Changes in the y-axis will be 1 pixel at a time. Okay, as you can see from here, it changes at 1 pixel. Now we simply have to find out the value of x for every corresponding y values. So what we have is we simply increment it by, we already know that the value of m is equals to 5, but the formula we have here is xk plus 1 is equals to x of k plus 1 by m, which is equals to x of k plus 0.2, because we know that 1 by m is equals to 1 by 5, which is equals to 0.2. Alright, it will be incremented by 0.2. Now the x value will be incremented by 0.2 only. Let's see. When x is incremented by 0.2, we have 3.2. This is your actual points now. 3.2. This part is your x value. X is always written first, and this is your y value. 3.2, 4. Alright, 3.2 is rounded down to 3. So the next step is 3 here, still 3 here. This is the 3, but y is incremented by 4. Next it will be incremented by 5, and so on. Okay, so next y is incremented by 5. Now the value of x is 3.4, but 3.4 is rounded down to 3 again, so it is still 3 here in this line, and we have this point. So likewise, all the x value is incremented by 0.2 as we calculated before. 0.2, 0.2, say 3.6, 3.8, 4, 4.2, 4.4, 4.6, 4.8, and so on. So 3.6 will be rounded up to 4. 3.6 is rounded up to 4. Now we have a change here from 3 to 4. Okay, so this is how DDA algorithm works. Now the previous cases that we have discussed is when m is positive. Now when m is negative, let us see. When the slope is negative and its absolute value is less than 1, we follow the same way in case 1, that is delta x will be equals to 1, and we have to find the value of y. Alright, and there is another case when the slope is negative and its absolute value is greater than 1. The following the same way in case 2, that is you take unit step of y equals to 1, and we find the value of x for every iteration. In the previous cases, we start from left to the right. If the state is reversed, Then, if the absolute slope is less than 1, set delta x is equals to minus 1 and y k plus 1 is equals to yk minus m. In this particular value, we change the value of plus to minus. Okay. Here, if the absolute slope is greater than 1, set delta y equals to minus 1 and xk plus 1 equals to xk minus 1 by m. Alright, so this is the cases, the 4 cases of the line drawing algorithm. That means in the previous example, we have drawn a line from here to this side. Suppose we want to draw a line from here to this side in this direction, then we have to take this kind of cases. Okay, or maybe we have to draw a line on this part of the side. So in this particular case, all these cases are covered. DDA properties, a faster method for calculating pixel positions than the direct use. Y equals to m into x plus b. This is your equation of line. Uses delta x or delta y to eliminate the multiplication in the above equation. Rounding successive additions of the floating point increment can cause the calculated pixel positions to drift away from the true line path for long line segment. Rounding and floating point arithmetic are time-consuming operations. Rounding up the floating points and siam rem teka a time-consuming vedewa. Mase kan ti tho nga ya chuan DDA algorithm hi lecture ma sa kan ti dan y equals to mx plus b hemi line formula pa ngai mathematics line formula pa ngai ya kan chut na ai kha chuan a all sum jok fe ne chan chu m value khan a increment pok pok me ni. So m value kha poimo m value khan yk plus 1 kha yk kha m value in increment pok pok ni ti ha kan thret kha tro kha zong kha tum tuma kan zir chu ni ro se. Thank you.